Hey guys, in this video I'm going to be going over connection to residuals. So the sub or Miss Kurowski should have given you this sheet. During this video I will also be referring to this notebook sheet of paper. This is this has all of the steps that I will go through written out if you want to pause the video and copy them down for your notes. So before we go on to number A, when we are asked to find the linear model, we want to go ahead and change our x values because it says let x represent the number of years after 1900. So our first step is going to change the x values into years after 1900. Go ahead and do this for the actual and predicted data tables so you do not get confused later on. So, from 1900 to 1900, how many years passed? 0. From 1900 to 1910, 10, and so on and so forth. Hopefully you realize that it's counting by tens as you're going down. And please go ahead and make sure you do the predicted values as well. Now the second step, regardless of whether the correlation coefficient is asked for, go ahead and practice finding it. You do this by clicking at the following buttons. So you're going to go to your calculator and you're going to click second, then 0. So mine has a blue button and I'm going to click 0. Now I can scroll all the way down to the D's, which may take a little while, or I can find the letter D and hit D and then scroll down. And what I'm trying to find is diagnostics on, which is right there. Now in the notes I say enter 2 times. So you're going to enter until it says done. After we do this, we're going to click Stat, and we're going to select Edit. This is going to allow us to enter our actual data. Make sure that you're looking at the left table on your sheet of paper. So we're going to use our new x values, which was 0, 10, 20, and so on and so forth, in our L1. So we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And we're going to use our y values, which was our population, and our L2. So that would be that 76, 92, all the way down our table. So we're going to scroll over, put 76, 92, 106, 123, 132, 151. So make sure at the end of putting in your data into your calculator that it lines up, that your last value in L1 matches the number of values in L2. If you do not do this, then it will give you an error if there's more values in one, less than the other. So once we have our data in, we're going to go on to step 4. So we're going to click Stat again. We're going to arrow over to Calc because we're going to calculate something. And we're going to select number 4. Number 4 is the linear regression. We're going to hit enter once. Now we kind of talked about this before I left. If you see a store anywhere on your screen, like mine shows, Then you're gonna follow this little star. If you don't have this window and you just have the linear regression and you have to enter one more time to get your equation, then follow these steps specifically, okay? Either way, you need to go to Mr. Vars. So we're going to go to the Vars button. We're going to ask why, Mr. Vars, is our function wrong? No, our function is not wrong, but that's how the saying goes, so you remember to select functions. So I'm going to hit enter, enter. Now, if you don't have this screen and you have the other screen, you only hit enter one more time. But for the people that do have this screen, you hit enter 2 extra times. So with this, you have your linear model given. The only extra step I put down at the bottom is to substitute your A and your B values into your slope-intercept formula, which was that y equals ax plus b. So you're gonna copy this down and put it for A. So you should have 2.02x plus 64.32. And to go ahead and have the information for us, I'm going to go ahead and put the correlation coefficient, which is a 0.981. So then we go on to B. Use the model to recreate the table, keeping the same input, but now using the predicted values as the output. So we're going on to number B. So the first step is to click y equals. Because we used vars, the linear model, it should already be there. So I'm going to click y equals, and it should already be there. Now click second graph so you can fill out your predicted table. So second graph, and there's our values. Remember, our x values are not 0, 1, 2, 3, 4. It's 0, 10, 20, 30, and so on. So on our table on our calculator, we're going to have to go to 0, and then we're going to have to write that value. We're going to have to go all the way down to 10 and write that value as well. So do that now. So once you have completed your predicted values, you're going to find your residuals. And that would be at number C, and that's what I have on my sheet for the steps. So there are 2 ways to find the residuals. The first way is to take each actual y value and subtract each predicted y value. So if you need to, write y value to remember which one you're looking at. Or there's actually a way on the calculator for the calculator to find all of these residuals for you. So we're going to click Stat again. We're going to select Edit, and then we're going to arrow over to where what it would be L7. And I missed it right there. It actually looks very blank. If you look at the very top right corner, it has an A on it. That means the alpha key is on. And we're going to use the green letters, and it may be not green on your calculator, but it's the little letters, and we're going to spell out resid. So R-E-S-I-D. Once we hit this, we're going to enter one time, and all of our residuals are now going to be in this list 7. So we're going to come on our sheet of paper and write all of these values. I'm using the third decimal place just to make sure you guys know all the decimal places. So now that we have all of our residuals, now we have to plot them. So this is still with letter C. So either way that you chose to find your residuals is valid. Now to create a residual plot, take your X values, which was your years, and your residuals that you just found, and plot them. An example is that your first order pair on your residual plot will be 0.11.682. So we're going to graph all of these, and then we can answer a few questions about them. So we've got 0.11.6, so we're going to start at 0. Remember, your year is your X, so that's going to be your horizontal axis. And your residuals are acting as your Y values, so that's going to be on the vertical axis. So 0.11.6. So roughly right there. 10, 7.4, 7.5-ish. 20 and 1. 30, -1.9, which is really close to -2. 40 and -13. Again, these are not perfect, and yours shouldn't be either. Just do roughly, okay? When X is 50, we've got -14 and a little bit more. So about right there. 60, -6.5, 6.6, so negative. and 70 is negative 2.8. So about right there. 80 is almost 1, right at it. 90 is 2.8. And 100 is 14.6. So about right there, roughly. So once we have our residual plot, now we've got to go to number D. Number D asks decide based on the residual plot if you think a linear model is best. Justify your response. So for letter D, we've got to decide if there's a pattern or not. There's no pattern due to the fact even if we connected our dots, we're not supposed to connect our dots, but even if we wanted to overthink it, there is no pattern to these dots. So there is no pattern. So a linear model would be best. Now for E. For E, to plot your data, click Y equals. So what we want to do is use our graphing calculator to graph our scatter plot. Once we do this, we want to look to see if our residuals or our data looks more like a linear, or exponential, or a quadratic. So we're going to go to our calculator, and it probably is turned off now, but we're going to click Y equals, and then we're going to select plot 1. So all I did was normally it is blinking on Y equals, and I'm going to arrow up to plot 1 and hit enter. What this does is it turned it on. So now go to your graph. So graph all points. Now, if you just hit graph, nothing's going to show up. For this data specifically, I'm going to go to Windows, and I'm going to change my window so that I can see all of my points. So for X min, I'm going to change it to -1. And you may have to clear it, -1. Then for my X max, I'm going to set it at 300. For my X scale, I'm going to keep it at 1. For my Y min, I'm going to have -1. And then my Y max, I'm going to set it at 300. Why I did this is because none of my X or Y values are negative, and my biggest number is at 281. So that 300 that I set my max to is going to be taken care of. And then I hit graph. So on your graph, you should have every single scattered plot. You also should have your line of best fit. So looking at this, you're going to make a decision of whether it looks linear, exponential, or quadratic. And I'm going to go ahead and give you my answer. In my opinion, if you look at it, it has a little bit of a curve, and it's only one-sided. So I'm going to say that it looks exponential. So now the next question asks us to find the exponential regression and the quadratic regression. So the only difference with this is that we're going to go back and repeat our step 4 from number A, which was finding our linear regression line. But instead of choosing number 4, we're going to choose number 5 and number 0. So we're going to go back to our calculator. We're going to click Stat. We're going to go over to Calc. And then let's do our exponential first. So we're going to go down to 0 or 10, whichever one you want to call it, and hit Enter. And this time we don't need to use vars due to the fact that we're not going to graph it. And hit Enter again. And there's our exponential regression line. So I'm going to take that. And remember to pause this video if you need to copy down something quicker than, or longer than I am pausing. I'm going to use that to write the answer for number F. Y equals 80.374 times 1.013 raised to the x. Now our quadratic. We're going back to Stat. We're going to calculate something. And we're going to go down to number 5, which is a quad reg. Hit Enter. I'm going to have to hit Enter all the way down. Some people are just going to have to hit Enter one more time. And then we're putting that also down. So y equals 0.009 x squared plus 1.85 x plus 78.357. Now, what I forgot to tell you with your exponential is you also go ahead and put your correlation coefficient, which was 0.997. And for your quadratic, it should be 0.99, and you round that third one because all of the other ones are to the third decimal, so it would be 0.998. And then H, I want you to answer on your own of the 3 models. So your linear model that we created in A, and your exponential and your quadratic regression. Which one do you think would fit best? Justify your answer.